All right, so you got to find the mean, median, and mode of the data set. Your teacher's not put this in order, which is frustrating. So you got to do that. 1, 3, 4, 5, and 5. 6, 2 7s, 1 8, and a 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. Okay, 1, 2, 3. All right. So once you get in order, pretty easy. You got to find the two middle numbers like you were doing last night.
Yep.
Median in this case is 5.5.
5.5.
Very good. And you split the data set right and down the middle. Find the median of the left. Oh, I'm sorry, you're not doing that. I apologize. Next is to find the mode. Mode's the easiest to find when it's in order. It looks like there's a mode of 5 and 7.
Okay.
The median and mode are done. So to find the mean, you do have to add up the numbers and divide by,
Okay.
or add them up and divide by the number of numbers.
Okay. 1 plus 3 plus 4 plus 5 plus 5 plus 6 plus 7 plus 7 plus 8 plus 10. 5.6 for the mean.
All right, let me double check you here. It's 5.6. Yep. And sometimes to show your work, you have to show the sum. But I'll leave that up to you to decide if you need to do that. All right, now they want you to know which measure of center best represents the data. Basically, you're looking to see if there's any outliers, any extreme values. I don't know. It's pretty symmetrical to me. So I think the
Yep.
mean probably the best one to use.
Hmm.
That would be my, but it's more about whether you say, okay, no outliers or pretty symmetric or not. All right. Why don't you do the same thing for data set 2? I'm going to use some software and we'll see how our results compare.
All right. So then for the median, I got 13. For the mode, I got 12. And for the mean, I got 13.8 repeating.
Okay, we got some different numbers in there. Let me just make sure I've done this correctly because I'm prone to making mistakes. 12, 12. Okay, yeah. So let me put the data in order now. Okay, so here is the data in order: 10, 12, 12, 12, 13, 14, 15, 18, 19, 20. Does that look similar to you? I'm thinking maybe you left out a 12.
There are 10 numbers.
Yes.
Oh, then the mean is 12.5. And then the
Uh,
median is,
the median is
is
13.5
13.5.
and the mode is 12, but the average is not 12.5. I got 14.5. And I'm using software which doesn't make mistakes unless you enter it wrong. Let's take a look there. It's easy to just miss adding a number. You know, if you're sounds like you might have been off by, I'm not sure, 15. But I'm gonna try adding those up one more time.
Okay. Calculation. 10 plus 12. 10 plus 12 plus 12 plus 12 plus 13 plus 14 plus 15 plus 18 plus 19 plus 20. 14.5.
Okay. Really good. Looks like the next grouping of questions is about box and whisker plots, kind of going backwards. They give you the information there, and you have to kind of fill in the blank here. So the median's kind of right in the middle,
Yep.
and you got Q3, Q1, min, max, and then some formulas. The let's see. So only formula you might need is for the range. Range is the max minus the min. Will you give me the values here for these whenever you got them down?
So 3 is 4, 4 is 8, 5 is 14, 6 is 14, 7 is 18, and 8 is 16.
Yeah, the language isn't great. I guess they are implying that's Q1. Sometimes they say the first 25%, and you just want to be careful that it actually is a number, not a range. But yeah, good job on that. So you're doing great here. Number 9. Looks like you kind of already made the box and whisker for this. So it's your 1, 2, 3, 4, 5, 6, 7. You put the numbers in order. 36, 40, 42, 46. Okay, good. 36, 42. Yeah, so when you cut the data set in half, you're trying to find your Q1 is from that one. So your Q1 should be over at 30. That's kind of come over here.
Okay. So then that's where I had it originally.
So it's when you have a middle number, you go left and right, same amount.
Okay. I had it at 30 first time.
And then you got the right Q3, you got the right max, you got the right min. I could see that you did get good enough there. So good, give the next one a try here.
Okay. 8. Right,
Are you asking me about the median?
no. So now I know the median is 8.
Yes, that's correct.
And split it down the middle, then. The third quartile is 9. Max is 10. The first quartile is 7 and the min is 2. Yep, that's what mine looks like.
Solid. Right. My question about 11 for you or thought is how you. I know you're visually inspecting it and saying, okay, that's the outlier because it's really far away. There is a way to do that. And I guess, do you know if your teacher wants you to do kind of we talked about the other day, the upper fence and lower fence? Or are you just supposed to eyeball it?
Probably just eyeball it.
Okay. So the outlier, it only affects the mean. Generally, the median is not affected and the mode are not affected.
Okay. Oh, cause it doesn't, cause um
So the like the
it's the
median
middle
of the
number in the
yeah, the
month.
middle number, it just swings either a little bit with a extra data point, whereas the mean it's contributing to it pretty. So part B, your explanation's fine. There's no issue there. Any questions up before we move on to 12?
Nope.
All right, so number 12 is so range isn't bad. Range is just, and maybe these are in order. Nope. All right, so they just be careful when you're doing your range that you really identify the max and the min. Let's see, it looks like 93 is the max. Min is maybe 87. Just 6. 3 400 minus 83. So here's how that impacts standard deviation is you would expect the one with the bigger range to have the bigger standard deviation. Does that make sense? It's
Yeah.
more spread together. Okay. To do that, first calculate the mean of each. I'll do the same. We'll compare.
Kind of confused here.
You have the mean for period 1 or
Hmm,
period 2. Sorry.
Um.
This one works out
yes,
nice.
Sorry. I accidentally cleared it on my calculator. The mean is 91.
It is
So period
91. Yep, very good. So let's just do period 2 for the moment here. And you have to make that table, which there's a fair amount of work to do in that. So you start by writing the data points, and then you have to subtract the mean and square it from each one.
Um.
So
So
it's like 92 minus 91 squared, which
Yep.
ends up being 1.
then you get 1, 9. Oh, wait, that's a 4. Okay.
Yeah.
And 87 minus 91 is, yep.
They're always
16,
positive, which is nice.
4. Okay. And then you add all those up.
Yep.
Plus 16 plus 16 plus 4 plus 1 plus 4 plus 9 is divided by 7.
And you have to take a square root of that.
Yep. 2.62 around.
Okay. Very good. Now the mean for period 4 is not as nice.
Okay.
In this case, when you get your mean, I guess we're going to round it to 1 decimal place.
Okay.
Let me know what you've got for that.
Uh, 87.71 or 87 or sorry, 89.7.
We're off again. 100, 88, 83, 89, 92, 91, 85. Is that right? Right?
Yeah.
Okay. Yeah, I got a different number. I got 89.7 if you want to check that again.
Yeah, that's what I got. That's what I
Okay.
meant. That's what I got. That's what I meant to say.
That's
I said
okay.
87.9.
No, that's bad. It's really bad because it doesn't work out nice. They don't tell you what to round to, but now you have to subtract each of those from it. So you have to take 100 minus 89.7 and square it. And then 88 minus 89.7 square it. And so on.
Yeah. That's 10.3 times 10.3. 106.09.
Here's where technology helps. 106.09.
2.89. Okay, so then those numbers
You add them all up,
What?
you add all the numbers up, right? Divide by 7 and take a square root again.
Yep. I'm in the process of adding them up right now.
All right.
And then all that divided by 7 is, and then square root it. I got 5.12.
You might want to ask your teacher about rounding, say, hey, how much, when, will you tell us what to round to? So on and so on. Now, comparing our results here, 5.12 compared to, I don't remember what Chico told me for this, but I'm guessing it was, pretty small, it was like 2 point something. What was for period 2?
For period 2 was. Let me find it. I know I had it. Oh, it was like, it's like, yeah, 2.62. Yeah.
Okay, so you can see that it is much smaller. 2.62 is much smaller than 5.12. They are asking you a question if it says to compare your results. And we already knew that. We knew that, okay, range is much smaller for period 2, therefore it's got a smaller standard deviation. Same with the range, larger standard deviation. Do you want us to do 13 or do you want us to move on to more stuff?
Move on to more stuff.
Okay, do you want me to, I'm gonna quickly check your answers for 14. Good, good. It's hard for me to read. 15 is qualitative.
15 is quantitative, or no, 15 is qualitative.
Yeah,
Right.
okay. Looks like it's whatever. There's a, as long as it's legible there. Okay. Okay, so 18 is a good problem. You see these on standardized testing. It's also kind of the like, what do I need on the the final to get a blank grade? So the way to do this is to find well, there's a shortcut and there's kind of the long way. The long way is to add up everything and divide by the number of numbers, set it equal to 3. The shortcut is to count the numbers 1, 2, 3, 4, 5, 6, 7. 7 numbers times 3 is 21. And then subtract out the sum of this. It's actually the same process, but intuitively it feels awkward. So what I'm saying is that because the mean is 3, the sum of all the numbers has to add up to 7 times 3 or 21. And we want to find the missing number. We're trying to find the sum of these, the 2 plus 4 plus 7 plus 2 plus 3. If you don't like that, the more standard way is to add up all the numbers.
Okay.
Plus X, divide by the number of numbers. What I think is maybe unclear is that you count the X, and then you have to solve this equation.
Okay, so then 2 plus 4 plus 7 plus 2 plus 3 is divided by, wait, what am I doing? I can just multiply by 7.
Exactly, yeah.
So then that's 18 plus X. So that's 18 plus X equals 21. The X equals 3.
Okay, let's try the same thing there for number 19.
Okay, so all that divided by 17 plus 15 plus 16 plus 18 over 5 equals 17. 17 times 5 is 85. Seven, 17 plus 15 plus 16 plus 18 is I got x equals 3.8.
Okay, that's way too far away. Sounds like, sorry, yeah, 17. It's got to be near these numbers. I mean, it can't be that far away. So like you said, it's 85. Well, what's your sum of 17, 15, 18, and 35? Or, I'm
35.
sorry, 17, 15, 16, and 18. Yeah, 17 and 18 gets you 35.
Yeah. And then 35 plus 31 is 66. 66 divided by 5.
Nope, no. You want to you want to clear out that 5 to start. You always clear
Oh,
out the number.
okay. So then, oh, I know what I did. I divided 66 by 5. Okay. So then it'd be 19.
Yes, X is 19. Okay, number 20 is kind of a standardized test type question where they give you two boxes and Whittaker plots, and they want you to compare. So they could be asking you questions about one or the other or both. In this case, they're asking about first about the shape of each distribution. You're looking for words like, when it talks about shape, you're looking for symmetric, skewed. What do you I don't know, do you see anything in either one? The other
Um,
the other thing to do here is to consider the median, kind of the peak of your distribution.
yep.
So you can see this one has a really long tail to the right. And then you can do the same thing for the other one. You can kind of, so kind of the peak there, there's that, and then this one also has a
Yeah. So
kind of a,
then the first one is skewed right. The second one,
I kind of
yeah,
say they're both tailed to the right, although th- these aren't distinct enough, but you might be able to say the first one's got a little bit of symmetry in it, but they're really both skewed.
yeah.
The second
And
one
then
kind
the
of looks like
first
a,
student was more consistent.
the other words that you can use to compare them. The consistency is like how much spread is there in the distribution.
Yeah, student
And then,
A was more consistent.
do you mean student one here? Just
Oh, sorry, student 2 was more consistent.
so the more consistent means that they have a smaller interquartile range.
Oh, I thought it meant smaller range in total.
Well, that's a good point. So you're right. You're right the way you said it. I'm right the way I said it. It depends if you're looking at the range or the IQR. You really can't give, that's why it says explain. You can't really go wrong either way. You just have to justify your answer.
Okay.
You'll hear this in the industry. It's like, well, what are we going to use to determine consistency? And if it's range, then you're right. If it's interquartile range, then it's something else. You have to know the criteria you're using to make that decision.
Okay.
All right. So who had the highest score?
Student one.
Yes. That's where you're basically just going and saying, okay, who's got the max? There's no arguing that. All right, any questions on that?
Nope.
Okay, so to do number 21, we need a little bit of information from you. All right, so to do a histogram, oh, they tell you how many intervals. That's good. All right, I didn't realize that. So they give you they tell you 5 intervals beginning with 127 to 142. That's really important. So what I like to do here is you almost want to make a table before you do it. So 127 to 142, that's your bucket or your width. And then you add in a frequency count over here on the right. We're going to literally count. Well, we need to add more buckets. So your next bucket is going to start at 143. And notice to go up from 127 to 143, the reason it's 143 is one more than 142. To go up to that, you added 16. You're going to add 16 over here. That becomes 158.
All right.
And then you go, okay, well, 159 to add 16 here, 174. And it looks like we do have to keep going. Let's see if I can get it in there. All right, 175 to 190. And I do think sadly we need one more of those. 191 to 206. It looks like that'll do it. All right, and
Okay.
then you go back to your data set and you just start counting and putting a tally mark is kind of the most common way of doing it. So I've got it up on my other screen so I can do this as well, or you can do it as well. But you just put a tally mark for each one that fits, and we'll just compare here at the end.
This isn't too hard.
Yeah, it's even better when you can use software and it does it for you.
And then you would just plot those points.
Yeah, now for a histogram, the rectangles are supposed to touch. Let's see, 1, 2, 3, 4, 5. So you kind of want to divide this up into 5. That should do it. And then you're really supposed to label them. I don't really have enough room to label it. Now I'm a big handwriter, but you draw your rectangles and they are supposed to touch. So the next one is 7, then 2, then 2,
Okay.
then 1. Some instructors are really picky about how you label them. When you use software, it labels it for you however they want it. If it's unclear, you edit it on your own. You're looking
Okay.
for the shape. You're noticing that more wrestlers are way less than way more. That's your kind of your like what can you glean from this information?
All right.
Which measure of center is the best? So because this is right skewed, positively skewed, if you were to like try to draw, distribution over it, you would see that it's right skewed. whenever it's skewed, you always use the median. So it
Okay.
doesn't ask for the median, it just asks for which measure of center to use.
Okay. So then,
Is that okay?
yeah,
Move on to 22. All right.
yep,
All right, organize a two-way table. You conduct a survey that asks 350 students in your class about whether they plan to go to prom this year. 171 males respond, 100 of which say yes, they plan to go. 90 females said they are not planning to attend. All right, so sometimes they give you, they've got to give you enough information to fill this out. And the idea is that if they give you numbers where my cursor is in here, and then you can add them up and get there. If they give you the total and then the males, you can find the females and so on. The 350 down here is your super total. That's the total in your population.
alright,
Okay. And then it says 171 males responded. So notice that number goes there, which means you can figure out how many females responded.
okay,
And then 100 males said that they were going. That's male and yes, that means they're going, which means that 71 said they're not going. 90 females said they are not planning to attend, which means you can figure out how many are planning to attend. Looks like 89. And then you can add up the totals. And everything has to sync up. So your row totals, your column totals, your super totals, they all have to sync up.
okay,
And then they can ask you a bunch of questions. Like B is just example of, I'll say, I don't know, 10 questions they can ask you about this table. But you have to get the table filled out to be able to answer this.
okay. Makes sense.
All right, if no student changes his or her mind between now and the prom, what percent of prom attendees will be female? So you're looking for the number of females out of the total.
Number of females out of total is 179.
Out of how many?
350.
350. That's it. No question, no other. I mean, I could ask you a lot of different questions on this table, but that is everything.
Okay, you know, I don't have
Alright.
any questions about that.
Okay. This next grouping of questions, what we were working on yesterday. What type of chart should we use? What type of display? And it depends on what what you have. So plant growth over a 6-month period. Notice there's time involved in that.
Yeah.
I'll have to pull up what we had yesterday, but if you remember what this,
Isn't that like line graph? I feel like it's a line graph.
right? Test scores for all of Mrs. Reif's algebra classes. Is that your teacher's name?
No.
Okay. This is kind of vague, but it's a lot of, it depends on how many numbers and whether we're actually comparing between classes. Now it says for all. So it could be, and I'm going to throw in 3 options here for you to look at because it really depends on, well, I guess it could be even a 4th option. Let me do this one more. All right. So any of these, I think would be reasonable for 24 for the test scores. The histogram depends on how many. Stem and leaf plot. Box and whisker plot's okay. Depends on what you're trying to show. Line plot is kind of the weakest, but it's could be any of these. So I'm not sure what to suggest. Maybe ask your teacher. 25 is about categories. Favorite video game. Do you remember which one refers to categories?
Bar graph
Yes.
or that circle graph.
So the circle graphs for 26 for sure.
Because it has to do with like percents and breakdowns.
Yes, exactly. It's like what piece of the pie that we're using in the budget for. So yep, pie chart. All right, let's take a look here, see what else you got. Bit more here. Yeah, so this is where I thought we were going with 27. Or with the earlier 2-way table. So the thing that you don't have that you need to add is a total and a total. And then that super total.
Okay, so then that'd be 59 and then 194. And in total that 253.
Okay.
It's 127. The bottom one's 127.
Okay.
And then that one is 126. And then
All right.
yes.
Now, and that's good. Now you can answer the questions. It says, what percent of bike riders are sophomores? So that's all the sophomores out of the total.
So
I'm sorry. No,
127 out
no,
of
I'm sorry. Hang on. I didn't realize what this is. They're saying what percent of bike riders? You're looking at people who ride bikes.
oh, so then it'd be of sophomore, which are 5 out of 59.
Yes. Now, the percent of students that ride a bicycle to school down here in C, I know we're skipping B, that is 59 ride a bike out of
Out of
250.
253.
Yes.
That's
What percent of
26%.
Yeah. And then what percent of freshmen do not ride their bike to school? So now you're looking at just freshmen. Just
Okay.
freshmen. So these problems are either looking at a column or a row. So what percent of freshmen do not ride their bike to school? 72 out of 126.
All right.
And then what percent of students surveyed are freshmen? 126 out of 253. All right, 28 looks like it's kind of a throw-in question here at the end. Oh, real quick, you should ask your teacher if you need to like round or you can put some calculator around to 2 decimal places, 3 decimal places, whatever. You just got to find out what they want. Okay. The box and whisker plot shows the results of a survey of 130 girls that asked how many pairs of shoes they owned. About how many would you expect to have between 15 and 18 pairs of shoes? So what percentage is there between 15 and 18?
what percentage?
Yes.
So it's like 3 out of 18, right?
So these are quartiles, right? Quartile one. Think of like
Oh, so it'd be
quartile.
15 divided by 18.
It's 25%. There's 25% in each quartile.
Oh, yeah, between each of the lines.
Okay, so we know there's 25% of 130. You have to multiply those together. 25% or a quarter of 130.
Thirty-two and a half. So then 33, because no, you'd round down because you can't create a whole new person.
All right. Yeah, you can find out about that. I agree with your logic on that one. You got to do something with it. Okay, we're going to go ahead and stop here for today.